Alright, number 47. The number of points scored by a basketball player in the first 8 games of the season are shown below. What would happen to the data distribution if she scored 24, 22, 27, and 28 points in her next 4 games? And look at all those answer choices. They're using the word peaked and widely spread. So we need to understand what those two words mean. Peaked refers to looking at bar graphs. If it's more peaked, this would be more peaked because it goes up more. And this would be less peaked because it doesn't go up as much. So just think of peaked like a mountain. If you graphed your data, here if you had a bunch of data in that range or that frequency, you have more of that data, so it's more peaked at a certain area. Okay, this one is more level. Most of the bars are closer to each other, and they're not going up way more than the other bars. So that's what peaked refers to. So we do need to graph it to see if they're peaked. Next, let's look at widely spread. Widely spread means that our data is going to cover a greater range. So it's going to have more range. So look at that second example, and you can see that the bars go further to the right and further to the left of the original example where they're just contained into 3 bars. So if you're using the same interval, and this graph is what you get for one set of data, that's the graph you get for the second set of data, the first one would be way less widely spread, and the second one would be more widely spread. And another thing is just look at the range. That has a greater range. And that's just the bigger number minus the smaller number, and this has a lesser range. Alright, so that goes over peaked and widely spread. Now hopefully we have a better idea what those mean. So now let's actually look at our data set. We're going to look at our first 8 pieces of data. We're going to graph them, and then we're going to add our next 4 pieces of data and see how that changes on our histogram. Alright, I'm going to break my data down into a frequency table. And I'm looking, the smallest number there is 15, the greatest number is 35. So I could probably just go by 5s. So let's say I wanted to do 11 to 15, and then 16 to 20, and then 21 to 25, 26 to 30, and then 31 to 35. I can make a table like that, and then I'm just going to make tally marks for each time they occur, and I'll go ahead and complete that. I'll start it with you. 15, I have one 15 or one number in that range. I have a 35, I have an 18, I have a 30, I have a 25, a 21, a 32, and a 16. Well, that didn't take long. So if I was to graph that, I would have, I would do 11 to 15. I just wrote all of those intervals down at the bottom, and now I'm going to graph them with a bar graph. Okay, and then my frequency is right here on the y-axis. It's how many times they occur. So 11 to 15, it just goes up to 1. 16 to 20 goes up to 2. 21 to 25 also goes up to 2. 26 to 30 goes up to 1. And 31 to 35 goes back up to 2. Alright, so now if we use our new data, I'm just going to indicate that with the color red. So 24 gives me a tally mark there. 22 also gives me one there. 27 goes in the 26 to 30, and 28. So the 21 to 25, that went up to 4. Remember that word peaked? That's peaking more, isn't it? And 26 to 30, that went up more. So that shows me that it's going to be more peaked, and my other bars all stayed the same. So it's not becoming more widely spread. the range did not increase. In fact, the numbers were more tightly together. They were closer to the median, the ones we added. So that tells me, if anything, they're going to be less widely spread. So I'm looking for less widely spread, and I'm looking for more peaked. It's got to be answer choice C. So that one's the one that's more peaked. It's definitely not more widely spread, as we said, because we didn't have any bars out here. There weren't numbers that were outliers or further away from the rest of the numbers. They were mixed in. All right. All right, number 48. The table below shows the shoe size and age of 7 boys. Approximately what % of the boys' ages is more than 1 year different from the age predicted by the line of best fit? We got to try this problem on using our calculator. So we're going to find the line of best fit. Do you remember how to do that? Well, we have an X and a Y. They already gave us the shoe size as the X, the age is the Y. So we go to Stat, Enter. All right, after we hit Stat and then Enter, we're going to type in the shoe sizes for L1, and then the age for L2. And after we get those typed in, do you remember what to do next? It's the Stat button again, and then Calc. And which answer choice looks good after you press that? It's one that says Lin Reg, which would be number 4. So we're finding the linear regression. And that gives you the A and the B values. So we write that equation down, and you should get y equals 1.126, and it says the x goes after the a because that's our slope, and then the b is positive, so it's plus 4.097, and I just rounded it to 3 decimal places. You definitely want to carry that decimal out a few spots to make sure your answer is accurate. Do you know what we do next? After we get our equation, we go to y equals. So press the y equals button. That's at the very top left of your calculator. And we're going to type that in. So type in the function, the 1.126x plus 4.097. And then we could graph it, but we want to know the actual numbers. So graphing it will just give us an approximation. How do we find the actual numbers? That's bringing up our table. So hit second and then graph. And again, the second button is right there, and the graph button is the top right. So hit second, graph, and it gives you your whole table. And it says, the question said, what % of the boys' ages is more than 1 different from what's predicted? So they predicted at age 6 that it should be 9. So let's see what we get for 6. 6 is, if you scroll down to your x, it says 10.853 for the y. Is that more than 1 different than 9? Absolutely, it's 1.853 different. So we would say a check there. That one's more than 1 different. What about, again, we're plugging in a 6 for x, so look at your table, and it says 10.853 again, same number. But how far is that from 11? Well, it's less than 1. It's like 0.147 away, so that would be a no. What about 15? So if we plug in a 7 for x, look at the left column. It says 11.979. Is that more than 1 different than 15? Absolutely. It's over 3 different, so that would be a yes. Scroll down to 8 for your x column. It says 13.1. 13.1 is more than 1 away from 11. It's 2.1 away, so that's a yes. Scroll down to 9. 9 is 14.2. So 1 away would be 14, so it's less than 1 away, so we would say no in that case. Look at, if we scroll down to 10, it says 15.357. And look at 16 and 15.3. That's like 0.7 away, so that would be no, it's not more than 1. And then our last one, scroll down to 12 in your X column, and we get 17.6. So that's only 0.6 away from 17, so that's going to be a no. So how many were more than 1 away? Well, there's 1, there's 2, there's 3, out of how many? 4, 5, 6, 7. So 3 out of 7 is what we're looking for. And remember, to make a fraction into a percent, you just do 3 divided by 7. That gives you your decimal, which is 0.4286 basically. And then to make that a percent, move it 2 to the right, and it would be about 42.8%, which would be closest to C, 43%. Notice they threw in answer choice D. If you would have misread the question and done 4 out of 7, 4 out of 7 would have given you the 57%. So just keep in mind that they did try to trick you right there.